The extraordinary revelation from the Tianwen-1 orbiter of 3IATLAS has effectively rewritten a chapter of cosmic discovery. This distant visitor from beyond our solar system, previously glimpsed only as a faint point of light among the stars, is now laid bare in its journey through space. An alien wanderer immortalized in images that carry far more weight than the pixels reveal. China's successful capture of the first real image of 3IATLAS marks a watershed moment, not just for planetary science but for the story of humankind's connection to the broader universe. Before we start, smash the like and subscribe buttons for more updates. Until now, interstellar interlopers such as 1I Oumuamua and 2I Borisov had teased scientists with tantalizing glimpses, leaving as many questions as answers. 3IATLAS, the third confirmed interstellar object, brought its own set of puzzles. Its trajectory unusually hyperbolic, its origin remote, its composition enigmatic. Then came the moment Tianwen-1 orbiting Mars turned its high-resolution camera toward this visitor between October 1st and October 4th, 2025, and on October 3rd, it specifically captured an image that reveals a bright nucleus cloaked in a broad coma, spanning thousands of kilometers. This one image is far more than a feat of photographic finesse. It is a bridge between earthbound curiosity and the deep mysteries of interstellar space. As the spacecraft's camera locked onto the faint object, here was proof that we are capable of reaching out beyond our solar neighborhood and capturing evidence of something from entirely elsewhere. The image stands as a testament to human ingenuity and to the vastness of what remains unknown. It evokes a profound shift in how we might view ourselves, not simply as residents of one small corner of the cosmos, but as participants in a universe populated by objects that predate our own sun and wander unbound through space. The implications of this moment are manifold. First and foremost, the successful capture of this image demonstrates the power of repurposing spacecraft designed for one mission, Mars exploration for another, a clever pivot that turned a Mars orbiter into a sentry for interstellar discovery. The image of 3IATLAS thus becomes both a scientific milestone and an operational blueprint. Missions designed for planetary reconnaissance may increasingly serve as scouts of deeper space, extending the utility of existing assets well beyond their original design. The logistical achievement alone, tracking a fast-moving, faint object from Mars orbit amidst background stars and cosmic debris, speaks to the maturity of our observational infrastructure. From a scientific perspective, the image offers a rare and direct view of a body hailing from outside our solar system. The bright nucleus surrounded by a large faint coma invites deeper questions about its composition, structure, and origin. Observations prior to this campaign had suggested that 3IATLAS is unusually rich in carbon dioxide and poor in water ice compared to solar system comets. Now, with the image in hand, models of its origin and behavior can be refined not only in terms of what it is, but where it comes from, what it has endured, and how bodies like this evolve across interstellar space. If, for instance, the coma structure and nucleus brightness imply a certain size range or volatile inventory, we can begin to ask, did this object form in a cold, distant region of a star system unlike ours? Did it get ejected during some catastrophic event? Does its condition reflect billions of years of exposure to galactic radiation or to passing through multiple stellar neighborhoods? The fact that China has released these images first adds another layer. In a landscape of increasingly complex spacefaring nations and shared scientific endeavor, the release of the first real image by the China National Space Administration shifts the narrative. Not only are interstellar objects becoming accessible to human observation, but the responsibility and privilege of detection are no longer the exclusive domain of a single international bloc. The global scientific community now has a fresh dataset to interrogate, compare, and build upon. The image from Tianwen-1 becomes a reference point for other spacecraft, ground-based telescopes, and future missions that may track this or other interstellar guests. In broader terms, capturing that image stretches the boundary of what near space means. Previously, observation of comets and asteroids from Earth or Earth orbit was constrained by line of sight, brightness, and instrumentation. Here, a spacecraft positioned around Mars reaches into a region of the solar system less charted for such faint targets and records something from outside our own solar neighborhood. It anchors the idea that our planetary exploration missions may double as gateways to interstellar science. The vista expands. Mars is no longer just the red planet. Orbiting spacecraft can become sentinels for the unknown. From a philosophical perspective, that image alters our cosmic self-portrait. Humanity has long gazed at the heavens, wondering what lies beyond the familiar planets and moons. To then see something that is not originally from our system, something that visited from the vast expanse between the stars, is profoundly humbling. It reinforces the concept that our solar system is not an isolated fortress, but part of a broader galactic environment in which objects travel, wander, and perhaps carry the chemical or physical legacies of entirely different star systems. Each such object becomes a messenger of sorts, not necessarily alien in the sense of intelligence, but alien in origin, carrying within it clues to cosmic history much older than the generations of planets we study. The timing of the capture is also remarkable. 3IATLAS passed relatively close to Mars in early October 2025, at a moment when the geometry allowed Mars orbiters to image it. The opportunity was brief and the brightness faint. China's ability to seize that window, turn its Mars orbiter's imaging system to a different purpose, and succeed in obtaining useful data signals a shift in agility and ambition. It suggests that, as more interstellar objects are discovered, we may not need bespoke missions to study each one, but can repurpose existing platforms intelligently. This event is not just a win in the catalog of space. First, it is a beacon for future strategy. It invites space agencies and scientists to reconsider their priorities, to think in terms of flexibility, and to view every spacecraft not just as its primary mission, but as a potential multi-purpose observatory. Already, the scientific community is scrambling to analyze the data, overlay it with past observations from Earth, Hubble ground telescopes, and future datasets such as from the James Webb Space Telescope. Each dataset now includes a high-resolution image from Mars orbit, turning what was once remote and mysterious into something we can inspect and compare. Asterisk in the context of planetary science and cosmochemistry, the image triggers a cascade of inquiries. What does the shape and brightness of the coma imply about the object's recent activity? Can we infer that 3IATLAS was maybe shedding material? Had it undergone a close solar passage recently? Was it structurally stable or undergoing fragmentation? Its hyperbolic nature indicates it came from beyond the solar system, but the image may help flesh out how long it has been traveling, how degraded it may be, and how much of its volatile inventory remains. Importantly, the image provokes the technological question: if we can capture such an object from Mars orbit, might we one day intercept or rendezvous with one? Could future missions be designed to tag undetected interstellar visitors or even hitch a ride? The image is a proof of concept for extraplanetary reconnaissance. Furthermore, this moment injects fresh energy into the search for interstellar objects. If 3IATLAS could be imaged this way, then perhaps the next one could be monitored with even greater resolution, tracked earlier, sampled, or analyzed. The scientific culture may shift from reactive discovery to proactive monitoring. The event breaks down the barrier between detecting an object far off and obtaining actionable imagery that informs composition, structure, and dynamics. It transforms a fuzzy bright dot into a scientifically meaningful target. It also impacts how we teach and conceive of cometary science. Up to now, much of how we describe comets is based on solar system examples, objects that formed near the Sun, perhaps from the Kuiper Belt or Oort cloud, whose journeys we can simulate in the context of our own planetary system. But 3IATLAS originates somewhere else. Perhaps from a star system with very different conditions. The fact that the image has shown it to exist at all within our observational grasp opens the door to comparative cometology across stellar systems. We can begin to ask, how does comet activity differ when the object formed in another star's protoplanetary disk? Are volatiles preserved differently? Does the morphology of the coma reflect unique conditions of formation or travel? The image makes these speculative questions real.